You've been stressed for months. Work, relationships, money, health, the usual things. And you've probably told yourself, it's just stress, I'll get through it. But here's what your brain looks like right now, on a neurological level. Your hippocampus, the region responsible for memory and learning, is physically shrinking. Your amygdala, your fear center, is growing more reactive by the day, and your prefrontal cortex, the part that makes rational decisions, is going quiet. Chronic stress doesn't just make you feel bad, it literally restructures your brain. And the most alarming part? It can happen in as little as 2 weeks. Stay with me, because what I'm about to explain will completely change how you think about stress. First, let's be precise about what stress actually is. Stress is not a modern invention. It's one of the most important survival mechanisms in biology. When your brain perceives a threat, it triggers a cascade. The hypothalamus fires. The adrenal glands release cortisol and adrenaline. Your heart rate surges. Your senses sharpen. Your muscles prepare to act. This is called the fight or flight response, and in short bursts, it saves lives. The problem is this: your brain cannot distinguish between a physical threat and an email from your boss at 11 p.m. Both trigger the same biological alarm system. Both flood your body with cortisol. Acute stress equals useful. Adaptive, temporary, chronic stress equals the same system, running nonstop for weeks, months, or years, and that's when the damage begins. Let's start with the most documented effect of chronic stress on the brain: the hippocampus. This is the brain region responsible for forming new memories, spatial navigation, and learning. It's also one of the only regions in the adult brain capable of generating new neurons, a process called neurogenesis. Cortisol is toxic to hippocampal neurons. In short bursts, it's manageable. But under chronic elevation, cortisol actively suppresses neurogenesis. It shrinks dendritic branches, the connections between neurons. Over time, the hippocampus physically reduces in volume. A landmark study published in Nature Neuroscience found that people with chronic stress disorders showed up to 20% reduction in hippocampal gray matter volume. This translates directly to measurable effects: difficulty forming new memories, trouble concentrating, feeling mentally foggy, even when you're rested. That brain fog you experience during high stress periods, it's not psychological, it's structural. Now let's look at what's happening on the other side of the brain. The amygdala is your threat detection center. Under normal conditions, it fires when real danger appears. Then your prefrontal cortex steps in to assess the situation rationally. Under chronic stress, this balance breaks. Cortisol actually increases the size and reactivity of the amygdala. More synaptic connections, more dendritic branching, a bigger, faster, more sensitive alarm system. At the same time, and this is critical, the prefrontal cortex weakens. The rational, decision-making, impulse-controlling part of your brain loses gray matter and reduces its inhibitory control over the amygdala. What does this mean in practice? Your brain becomes wired to react instead of think. Small threats feel catastrophic. Rational decisions become harder. Anxiety loops form because your amygdala fires constantly and there's nothing strong enough to tell it to stop. Chronic stress doesn't just make you anxious. It structurally builds anxiety into your brain. But here's the part that surprised me most, because the damage doesn't stop there. Chronic stress is also rewiring the way your neurons communicate at the most fundamental level. Under normal conditions, your brain is constantly forming new connections. This is neuroplasticity, the brain's ability to adapt and rewire. It's how you learn, recover, and grow. Chronic cortisol exposure hijacks this system. It shifts synaptic plasticity from the prefrontal cortex, the thinking brain, toward the amygdala and striatum, the reactive, habit-forming brain. In other words, the more stressed you are, the more your brain automates fear responses and the less capable it becomes of deliberate, flexible thinking. And the regulatory system itself, the HPA axis, becomes dysregulated. Normally, cortisol has a feedback loop. When levels get too high, the brain signals the adrenal glands to stop. Under chronic stress, this loop breaks. Your brain loses the ability to downregulate its own stress response. You become trapped in a biological cycle. Stress leads to cortisol, leads to brain damage, leads to more sensitivity to stress, leads to more cortisol. This is why chronic stress feels impossible to escape. It's not a personality flaw, it's a broken feedback loop. If this is making you look at stress differently, subscribe. Every week, we go this deep into the science of your body. No fluff, just evidence. Now, here's the important part, and the reason this video doesn't end on a dark note. The same neuroplasticity that chronic stress hijacks can also reverse the damage. The hippocampus can regrow neurons. The prefrontal cortex can regain volume. The amygdala can reduce its reactivity, but only under specific conditions. In 2018, a Stanford study showed that chronic stress-induced brain changes began reversing within 4 weeks of stress reduction, when combined with specific behavioral interventions. The brain is not permanently broken. It's waiting for the right biological signals to repair itself. So what are those signals? First, aerobic exercise. 20 minutes of moderate cardio directly stimulates BDNF, brain-derived neurotrophic factor, the protein that drives hippocampal neurogenesis. It's the most evidence-backed intervention for stress-induced brain damage. Period. Second, sleep quality. As we covered last week, deep sleep is when your brain consolidates and repairs. Poor sleep and chronic stress form a vicious cycle. Break one and you weaken the other. Third, controlled breathing. Slow diaphragmatic breathing activates the vagus nerve, which directly signals the amygdala to reduce reactivity. 5 minutes, twice a day. Measurable cortisol reduction within 3 days. Fourth, cognitive reframing, not positive thinking. Reframing. Research shows that labeling an emotion, "I feel anxious," reduces amygdala activation by up to 50% in real time. You're giving your prefrontal cortex back its role. Here's what we covered today. Chronic stress physically shrinks your hippocampus, your memory center. It enlarges your amygdala, your fear center. It weakens your prefrontal cortex, your rational brain. And it breaks the feedback loop that's supposed to turn stress off. But your brain has neuroplasticity on its side. With the right interventions, exercise, sleep, breathing, reframing, the damage reverses. Stress isn't just a feeling, it's a biological process, and biology can be changed. Next week, we're going inside your gut, because the gut-brain axis is one of the most fascinating and misunderstood systems in human biology. Don't miss it. Subscribe to Healthy Body Science if you want more science-based insights that help you work with your body.